I am going to show the integration or the work that we can do between Power BI and R to do some data science and machine learning work. The example that I am going to use in this case is no machine learning, it's data science. After I am going to explain why. So we are going to have the introduction, which I am going to explain some concepts. Then we are going to have the business case, probably if we have time, an additional business case, and the conclusion. Well, initially, I am going to start to explain what is data science. Data science is a new concept. Many people define the concept like putting together statistics, machine learning, data analysis, all these concepts to solve a problem or a challenge using data. This is the key part there, using data. Generally, when we do business intelligence, we probably embrace the descriptive analytics and the diagnostic analytics. When we do data science, we go further and we do the predictive. And now people are talking about the prescriptive analytics, which is more about recommendations. This project, it will take the descriptive, diagnostic, until predictive. We are not going to do anything in prescriptive. The methodology that we are going to use is the data science methodology, which starts with the business understanding. We do the data preparation. We do some exploratory analysis. We do the modeling. We evaluate the model, and we deploy it. We are going to do the evaluation of the model using accuracy performance. That will tell us if the model is good or is bad, and if we can choose it. In Power BI, there are 3 ways to do the integration with R. One is getting the data. The second one is using R to deploy visuals. And the third one is basically in the Power Query. The visuals using R are pretty ugly, so we are not going to do that. I am going to use the integration, getting the data using the script with R. The business case. Well, the business case that I have has as objective to predict the Medicare benefits for the years 2017 and 2018. Medicare benefits is what the government pays when you go, for example, to the doctor, and you do actually get a rebate. This is what the government covers. We are going to predict that expenditure. So there is some data available in data.gov.au. And we are using that data to do that prediction. The methodology that we are going to use is we are going to use 4 forecasting models, which are these here: naive, exponential smoothing, ARIMA, and Prophet. I am not going to go into the detail to that because this has a strong statistical concepts. And in machine learning, in data science and machine learning, it's not about statistic, it's about prediction. So I am going to do just this explanation. This explanation is really short because this is more complex than it looks. But we are going to just, highlight what is, For example, the naive one is easy. It's the simplest one. We just take the last period. For example, if the time series has seasons, we take the last season and this is our forecast. That's it. It's pretty easy. It's the simplest one, and it's generally not used as a model. It's used to compare, because this is the worst one that we can use. The next one is the exponential smoothing, which is a weight average of the past observations, and it gives the high weight to the recent ones. This is what it does. The ARIMA one is pretty similar to exponential smoothing, but it takes in consideration a new concept that is called autocorrelation. This has a strong statistic component. I am not gonna go through that because there is a document, and probably I can send you guys and you can read about it. This model is very statistic, and this is the reason why many people don't consider ARIMA as a machine learning model, because it embraces too much about statistical assumption, and machine learning is about prediction. They don't care about the statistical assumption. If the model is accurate, cool, it doesn't matter the rest. And we have the last one that is Prophet, which is the Facebook one. This is the latest model released by Facebook. And it's similar to the other one, but I take in consideration the seasonality, and it gives like a strong weight to that. It takes in consideration the holidays, etc. Okay, now we are going to start. This is the data. This is the current data that we have. We have data from July 1993 to June 2016. So what are we going to do here? Basically, we are going to split this data between the training set and the test set, which is everything that we know. And what we don't know is the forecast, which is going to be July 2016 to June 2018. Even though this already happened, the data in data.gov.au is not available yet. So we are going to actually use that. How we are going to see if the model is good or bad? At the moment, the government released last year some statistics about this information. We are going to compare it, and we're going to say, okay, the model works or it didn't. Any question until here? So this is pretty important because here, this is what we are going to do in the other slide. So we are going to actually generate the forecast, and we are going to compare the values with the test set and see if, how accurate we were. The process that we're going to use here is we are going to take the 38 million rows and aggregate it in 270 observations using R and Power BI, and after we do the deployment. Demo. Okay, let's start. So in R looks like that, and here I have, I have the algorithms ready. I am not gonna go through these algorithms. These are all the algorithms for every single model. They run here. When you run the algorithms in R, the conclusion looks like that. It's pretty ugly. It doesn't say much. We actually cannot do much with that. So what are we going to do in Power BI? In Power BI, the first step is, we are going to get the data. I am just going to simulate one. We use the R script. We copy all this script, and we put it there.
Did you write the script, or is it a sample from somewhere?
No, I did it. I forgot to say, this is basically was a project that I work on when I was doing my master's in data science. Mm-hmm. So we paste that, and the data is gonna come to Power BI as a data frame, as a tables. So you are gonna see the tables there. They are already in the model, so I am not gonna bring them. It's just to show you. So these are all the tables that the algorithms generate, and I am gonna copy all these tables in Power BI. Then I am gonna play with it. These tables are at the moment here, so I already did everything. Okay, so we start with the first step of the process, which is just doing the exploratory analysis. Let's understand what is going on now, So at the moment, these observations are telling us three things. The first thing is there is an uptrend, as you can see, when the years, over the years, the benefit is increasing. We can see that clearly. Also, we can see that a pattern or a season. Probably we cannot see it there. We can see it if we do this. We can see that is something happening. For example, in January, there is always a drop, and in June, it's always an increase. So we can see that is some season in the months. And also, we can see there that when over the years, when we are going up over the years, the variation in the observations increase. In a statistic, they call that as a multiplicative trend. So we need to know that thing just for that. So after we see that, we see here that we have the training test, and we have the training data set, and we have the test. Let's start to apply the algorithms. So the first one is the naive. So we have the results already there. As you can see, it's taking the last season, which is this one, and replicate it over the years. It's not doing anything else. The model, as you can see, is pretty bad. It's pretty different to the current data. So it gives us the accuracy metric, which is 198. This is the RMCA, which is the root mean square error, and it's gonna be the metric that we are gonna use to decide which model is better. If the next models are higher than this one, they are really bad. We can actually not choose it because this is like our base point. So we check the ETS, and we can see that the model improved. The RMC is lower, and we can see now that the model is like following the trend, it's following the variation, and it's looking much better. Okay. After we see the ARIMA, and this model is better than the naive one, but not much better than the ETS because the RMCE is actually higher. So, okay, we are still, at the moment, the ETS is the best one. And lately, we see the profit one, and we can see that our RMCE decreased to 96. So this one here, if we compare the profit model with the ETS, we actually can see that the profit model is the one that can help us to actually do a really good forecast. So we are gonna choose that one. We already evaluate the 4 ones using an accuracy metric, and we are gonna choose the lowest one because it's basically these metrics. What it does, just to give a quicker explanation, is the difference between this point and the other point summarized. So it's actually the variance that is between them. So if this variance is smaller, it's better because it's fitting well the data. So here then we choose the profit model, and then we proceed to do the forecast. This is our forecast. This is the data that we didn't know, and at the moment we are generating this information. Because this is something that already happened, what I did was I took the information from the government statistic, and I checked, how accurate I was in my model. And you can see here, this is the actual expenditure of the government, and this is what I forecast. You can see that the difference is a slight difference. It's 1% in 2017 and 0.3 in 2018. This looks like very small, but in terms of dollars, it's quite high. It's like around 300 millions, I think that it is. So when I present this model to my mentors and to the Department of Social Services, the feedback that I got was that how you compare that the model is good or the model is bad or the forecast is generally what you do is that you can use, in this case, they suggest to use the budget or to use the current expenditure, and this is what I did. And after we present it back, and then we decide that the model is actually working well. So this is basically a data science example using open data. The other business case that I have here, which I am going to show you guys before we go to the questions. This is a real one that is happening now in one of our clients. And I took some data just to do some experiments and to see if actually the model is going to work in that data as well. And there are many good things to see. This is the data of the client. This is what is happening now in the cells. I am not going to say the name of the client because this is this is like pretty confidential. So this is basically the sales versus budget versus the forecast that I am doing here. Probably let's take the last year so we can see like more information. Let's take 2019. Okay, this is 2019 data. The blue one is the actual, the green one is the budget, and the red one is the forecast that I did. So this is the data that they currently have, and what I did is I did exactly the same that I did with the Medicare data, and I generate a forecast. And I am going to compare that forecast with the budget that they use, and then we will see if the model was cool. So here I did that. So on the top, you can see the actuals in comparison with the budget in 1 week. The difference is 13%. With my forecast, it's only 0.6%. So at the moment, I haven't presented that to the client because what we want to do is like initially like ask them to do it because I actually did it, with a permission. But it's actually showing that it's working, only considering seasonality, and external factors. I haven't considered anything like internal in the company, like how the sales and all that, just about data. And actually, the model is performing better than the budget that they have. So I just wanted to show you that, so to see, the things that actually we can do when we, when we understand, all this modeling part. Any questions? It was too hard? Please tell me. I try to make it like statistical minded, just more the analysis. But yeah, you can say anything anyway. What do you think?
Can you dive a little bit deeper into the statistical side of it in terms of what model are you using to predict this? The client who's nameless, who has a huge spike in November. What, is it the profit model? Or?
No. So in which one do you want me to?
The client one. Yeah.
The client. So in the client one, I used 2 models.
Yep.
The ARIMA model and the profit one.
Okay.
The problem with the ARIMA one is something that, when you start to work with the ARIMA model, you need to achieve a statistical assumption. And if you don't achieve those statistical assumptions, you can't apply the model. Mm-hmm. So then what happened, because you are doing everything to achieve those statistical assumptions, the model worked really well in the training, but when you put new data, it crashed.
Yep.
So that's called overfitting. And this is what is happening.
Okay.
The model, people say, ARIMA, you can, do many things, but overfit the data so much because you have to achieve those statistical assumptions, like, the residuals have to be 0 and you have to be autocorrelated and so much crazy stuff that you train the data pretty well in this here, in this part, in this test, but when you put new data, forget it. Yeah. It's not picking up. Yeah. And in machine learning, the point is not like if you achieve the assumption or not. The point is if you actually predicting pretty well. Yeah. If you don't, forget. I don't care about the statistical assumptions. So here in this profit model, it doesn't take into consideration any statistic. It's just algorithms there. So if the explanation in the profit is like statistically there is no explanation, it's mainly taking the exponential smoothing one and applying a strong, high effect in the seasonality. This is what the algorithm does. And also some people, what they do, they generate the profit model and also exponential smoothing, and the result is an average between those. Some people have shown that actually it's better. I didn't do that because it's like, I don't have still the confidence to do it because you have to explain that to the client.
Yep.
You know what I mean? So, but with this one, probably what we could explain to them is that we are taking in consideration the high seasonality during the day, because actually this is a daily data. And then we are going to use that high seasonality to predict the forecast in the next week. Also here, when I did the prediction for a month, I wasn't that accurate. So only for a week. I was like, cool. For a month, I wasn't that good. Probably the model, has like too much variance that it can pick up like too much data to test. But yeah.
So how much time did it take to put something like this together?
Okay. In this case, I had to generate this algorithms. It was pretty easy because I have I already been working with this. So it just was, putting the data in the right way and then apply the same algorithm. So that took me like 2 hours.
Okay.
But because I have the data.
Yes.
And I used to work before with the client, and I knew. So when I was working with the client, I was seeing the data. I said, oh, this data looks so cool. You know what I mean? And I talked to them and I say, look, here we can do some forecast, but they say, no, we are not interested in that at the moment. We just want to see, what is happening now, not what is going to happen after. Because we have another team that is worried about it, which is the budget team, the planning team. Yeah. But now I am actually showing that we have a better model than them, what I mean? But I cannot go there and I say, because they are going to come and say, no, look, but you are not taking in consideration this, for example, this part of the business, or this. I haven't, I've just been using the data.
So this is based on aggregate data, but if you start to break it down into like individual parts of the organization or individual types of product, does it get more difficult depending on the cohort size? Or?
Yes. So it's when the model gets really complex, because it's another modeling that is called, is in hierarchies.
Yep.
And you have to do all this stuff depending on the number of hierarchies and after consolidate. So it's when the model gets a little bit complex, but we could do that. Okay. Yeah. It will have to be running using another kind of modeling, but yeah, this is what the advanced analytics take. This is a simple one. As you can see all these algorithms, but it's actually simple because it doesn't take in consideration all these hierarchies. But yeah.
So in the Power BI dashboard,
yep.
Is that just a visualization? Can you sort of interact with some of the dates and say, look, let's cut out anything before 1995 because that was before we kind of did any real business or anything like that? Or
so here, to be honest with you, the integration in Power BI at the moment, Power BI here just doing the deployment.
Yep.
The machine, the algorithms, the modeling, the extraction of the data, everything is running R. Here, this is my.
So you run it in R, then you dump the data set back into Power BI.
Yes. So what I do exactly. So what I do, because in R, look, this is how it looks, Marima. I cannot do much, So this is like very static, and this is how it looks. All this, looks like really bad. Yeah. So it's like you can have it, and then I do my model here and I test it and I get it, and after I pass it here and I make it more presentable, so actually I can, filter the data easily. Here to filter the data, I have to actually run a code, So here is just a click.
Okay.
See, this is what I try to do. So the business, the stakeholders, they actually can play with it, without, we saying too much. But yeah, here the integration at the moment is like that. This month, as I said to Brad, the release of Power BI is like no coding. You are going to be able to do machine learning now without R, just in Power BI.
And what will they expose it to all? Do you have any indication on?
So what they did in November. They made an announcement and they gave to the first 1,000 people to click like the preview. I wasn't, so I don't know how it looks like. So many people know how it looks like, but this one is gonna be public.
Okay.
So we are gonna see how it's gonna look in. So you are gonna be able to do everything: run the model, test it, get the evaluation, and deploy it.
So at a high level, could you summarize for everyone, like what type of data should we be looking for in order to be able to run these kind of statistical techniques across?
Okay.
So less in terms of the trends in the data or anything like that, but more just from the business side of things. If you have data that looks like this, you should be thinking about putting machine learning over the top of it.
Yeah, exactly. So I think that in this case, in this case that is more forecasting. We are not doing like any hard prediction or classification. Anything, for example, that is sales, spends, that when we see the business that is very focused in the planning and say, look, we want to be more accurate in our budget because this allows us to plan, this allows us to present the information to the shareholders about what is going to happen. That's a good thing to apply this, because what we could do is like, okay, you are doing your budget, but they also do a forecast. They do the budget for the year, but also they compare and they say, okay, we have the budget, but many things change during the year, and they start to use the forecast, which is telling them, what is happening. So it's when actually we can use that. How have to be the data? Well, in this case, for example, the data was like that. So let's, for example, check one. Let's check this one here. And it looks like that. The data was by year, the state, the age. You could do a lot. You can do the forecast by state and all that stuff, but that will make it more complicated, And also because the data was 38 million rows. So what I did there was like summarize all the information by Australia, and then organize this information in those observations over the year and do the forecast.
Can you show the preview of the fields that of the tables that you dragged into Power BI?
Yeah.
How would the algorithm look in this table?
Okay, so let me just show you here. Dun, dun, dun. So for example, for the ARIMA, what I bring the the information, so like the values and also the date. And the same for the other ones. It's the same, like the date and the benefit paid. For the naive, it's the date and the benefit paid.
So this one, then you select a chart, which is a line chart, and then just convert the table into a line.
Because what happened is like I didn't do the transformation in Power BI.
Okay.
I did it in R for one thing, because when I tried to do it in Power BI, it took me like 1 hour. Why? Because I am using the Power BI, the free one. If we had the premium one, yes, it's gonna be better. So what I did all the transformation here in R, which is here. This is the algorithm that I take. So this.
That's the output of the
Yes. Algorithm. So if you run this algorithm in R, takes like 5 minutes, and it's gonna show you this table that I have here.
Yeah, this one.
This one, but with all the data, 38 million rows. There, yeah. And after I convert that in a time series, this is what I basically.
So if you're looking at a forecast value, let's say a day, a month out, can you look at the components, or can you reverse engineer how that was calculated? Does the algorithm give you it's like 80% this value last year, and then adjusted by the trend of this?
No.
You don't get a formula.
No, you get the output, So yeah. So what I try to do there, for example, here in this one, when I got the output, because I got the output and I start to to actually compare by value, by month, and start to analyze variance, because I know that this is when I go to the financial controller, this is what they do. They start to check like the variance, but the algorithm doesn't show that. We have to do like some exploratory there. Yeah.
Okay. So it's not like a multiple regression where you could
yes.
weight the things differently or include or exclude different variables, or.
Because in this one, because it's the ARIMA one, the only variable that we are taking in consideration here is time. But if you are another, for example, if you say, okay, I am gonna forecast, but I am gonna use time, but I am also want to use the index of the prices, you can put it in there, and yeah, we can see the relation between those variables. But in this one, the only predictor of the variable predictor is time. There is nothing else.
Okay, so you can't really overfit with that model either, can you?
Yeah, you can. You can if you tell because this is the simple one.
Yeah.
We are not putting any variable. But if we want to be like more complex and we analyze, like for example, the population in Australia in comparison with this, we can put that. But the model is going to be a little bit more complex.
Yeah. So that's when if you have a lot of parameters, you can overfit, right?
Yeah. Exactly. If you have too much,
It's just got the time parameter, right?
Exactly. At the moment here is the time one, but when you want to be a little bit more, complex and in detail, you can add others. And the model is called dynamic.
Okay.
Yes. But yeah, this is I haven't worked with that one yet, but yeah, will be cool too, because some companies will say, okay, like this business, they say, okay, we forecast, but we take in consideration the time, but other variables too, which I didn't have in consideration here.
Okay.
Yeah. Anything else?
What about something which is unusual? For example, this is for usual data.
Mm-hmm.
Yeah.
When something happens unusual, how can you predict it in your model?
Okay, so here I will show you this one. This is a cool question. The only one that can do that is the profit model. Here in the profit model, I actually put the days that I consider that was unusual, and those days were the public holidays in the business. So I actually saying here in the algorithm holidays, and I put the days, and the algorithm take in consideration that they were outliers, and it's going to represent that in the model. This is the reason why this one is the best one. In the other ones, I cannot do that. Actually, I have to do a transformation in the data to show that something happened there. But in this one, automatically you can do it. Yeah, that's the reason why this model is the best. Because it takes in consideration outliers and things that you say, look, this day is unusual, put it in, and the model is gonna take in consideration that as a parameter, and it's gonna run it. Yeah. This is a cool one. This is the Facebook one, the model from Facebook. Any other question? You guys there?
You got a question?
Oh, hello.
No questions.
Okay, guys, thank you for coming. I hope that this helps a little bit. Next time we are going to do the same, but no coding. It's gonna look like this. No coding, zero coding. But we are gonna. Yeah, okay. We are gonna analyze some information and using like this ETL tool that is called Azure Machine Learning Studio. The tool is made for that. No coding, and everything is in one platform. We don't have to jump between both. And when Power BI release the new machine learning tool, then we can do the same. We are gonna take the same model, we apply it, and we see if we are good or not.
Okay.
Yeah.
Very good.
Thank you.
Okay,
Thank
cool.
you.
Thank you. So I see you in the next one.